algorithms. Some key concepts in machine learning algorithm and also application of machine learning. That is how this machine learning is being applied to usefulness. Then challenges we see or face in machine learning. Then what the future of machine learning looks like, how we can predict based on current happenings. And also we can ask questions. So at this point, let's look at introduction to machine learning.
Yeah, please make it full screen. Click on slideshow and make it full screen.
All right. Okay. So machine learning is a subset of artificial intelligence.
Hello, can anyone still hear me?
Yes, I can hear you.
All right, thank you. So I guess he's having network issues. Please, let's be patient. Thank you.
Oh, sorry about that. Please, I will be sharing my screen once more. Oh, please enable me, give me permission to share the screen again. I'm sorry. Please, I will need the permission to share the screen once more. Thank you. All right. I'm sorry. Okay. So we're looking at machine learning introduction, and I said machine learning is a subset of artificial intelligence, enables system to learn from data and improve performance over time without explicitly programming or writing the codes to carry out this function. So let's just give it a quick overview of what the definition is. Now, say a simple explanation could be learning or teaching a computer from experience and improving it without being without saying in clear terms that okay, you have to do this at this point. So because the system has been trained to know that at a particular time or at a particular given data, this is the output is expected to return, and that can only be achieved with training those models, training this set of data time and over time to be able to recognize those data, those patterns, and when to give a report according to what is being visualized. So that's just a summary of definition here, but I want to read all through. For a layman understanding, this is how we can best understand this issue of machine learning. Now, imagine you want to teach a computer. All right. Now imagine you want to teach a computer to recognize photos of cats, for instance, and you have to show thousands of these of cats and those that are not cats. It will learn to identify features and distinguish cats from other things. Now, the more data is processed, the better it gets recognized that okay, this is actually cat or not cat. Now, if you look at how machine learning works, we have for us to, set up a proper functioning learning algorithm, because at this point we won't say we can have a set of data that recognizes pattern without setting up an algorithm that's able to recognize, that is able to follow suit or follow patterns, follow orders. Now, for us to know or for us to get hold of this, we have to understand how it works. First, there is a need for us to collect data. Now, machine learning requires large amount of data, and that is true. The data, sometimes the quantity of the data could determine how effective your models as well as your final predictions. So the larger the data, the better your chances of getting recognition feedback. Because don't forget, the aim is to for it to recognize patterns. And if you can give it a very large sum of the data from different source and different formats, all pointing to one aim. Let's say, for example, we are giving here is a cat, and you can feed in different type of dogs, cats, non-cats, or having 4 legs. It can be able to distinguish, okay, no matter how 4 legs or how smart or tiny or big the animal with 4 legs is, this one is actually a cat and this is not a cat. So the quantity of data could be helpful. Now, data processing, before training data is cleaned and transformed to ensure quality. This might include handling missing value, normalizing features, and splitting data into training and test set. Now, at this point, for us to be able to train the data, for us to be able to make use of the data, we have to do some cleansing. Oftentimes, when we get data from any of our sites, for instance, if you go to Kaggle data set, the data may be having some null values and empty space between it. We have to cover up for them. We either fill them with something or we close them entirely and don't let it remain blank. This is part of the data cleansing we are talking about here. Now, we have to set those data in a proper mode to enable any form of unnecessary error due to jumps. We have to let the data well structured for further modeling. Now, choosing a model, one of the things you may want to do immediately after cleansing the data is jumping straight into choosing a model. Now you ask yourself, what model am I choosing? How do I determine the models to choose? There are different sort of models depending on the task. We have the classification regression, for instance. Now, different algorithms are chosen. Common algorithm include decision tree, support vector, machine, and neural network. Now, these all the models we are choosing are determined, or we choose them based on what the aim is. Now, for instance, if you are having some set of emails into your phone, into your email address, and some of those email comes in forms of spam, and the other ones in normal setting, which is not spam. At this point, we may want to these are just two options to choose from. You may ask yourself what model, because it's the structure of the data that could often determine the structure of the data together with the expected prediction. That's what you are looking at, the data type and the prediction type. Now, in this case, we are looking for two things and not more, which are the spam, those emails that comes in as spam, those that comes in as not spam. So you have a variety of model. You can see that your option is now narrowed to those ones that could actually test for effectiveness test effectively for just two variable or two outcome to monitor. So at that point, you begin to drop other models and look for the one that best fits these two. Now, we'll look at some of these models we're talking about later. But at this point, we look at data processing. Before training data, okay, we talked about choosing a model. I just mentioned some, models here. And just a few, we'll look at more the next page. Now, type of machine learning. We have the supervised learning and the unsupervised. Now, in the supervised learning, the machine learning algorithm is trained on labeled data, where the correct output is also known. Here, when we talk about labeled data, now we are looking at data with sort of identification. You have something used to identify those data. For instance, you want to train data involving cars or brands of cars that are let's be for example Toyota, and the Toyota set of cars, you give them the label, or they are being unique to their shape. Okay, see, every car that comes in this format or in this form are all Toyota. You label. Now, due to that labeling you give to it, due to the other features, this could be the shape, the formation of the glass, how the vehicle is, the machine, then the model can tell, okay, this is actually a Toyota. Now, at that point, that set of data or objects is being labeled. So it will learn from the pattern of the label, from the naming of those vehicles, and together with what features it can recognize in it. So the algorithm learns to map inputs to output based on labeled data. Another example we can give is some set of objects put side by side. You name these ones fruits, then the other ones are non-edible, let's say like household items. Then over time, the machine model gets to recognize those that are fruits and those that are not fruits based on the object structure and labeling. So we have this unsupervised learning. At this point, the model finds hidden patterns in unlabeled data. The machine learning algorithm is trained on unlabeled data. It must find patterns on relationships in the data of its own. The algorithm does not have any prior knowledge of the correct output, and it must learn to identify underlying structure of the data. At this point, you are not adding any sort of name. It only gets to recognize things and store them in its memory due to overtime recognition. So that's for unsupervised. And an example of unsupervised learning is the customer segment. For example, now in marketing, you can use cluster algorithm. Now, before we talk of cluster algorithm, this at this point may sound unfamiliar word. We'll come back to type of algorithms, but let's just continue. So in marketing, you can use cluster algorithm to group customers based on similar behavior or characteristics without any power label. Yes, sometimes we want to use customer behavior characteristics to, we are taking ourselves, for instance, like a model that is meant to recognize behaviors and patterns. The same way with the way we set up or program these models to function. This customer, sometimes we only get to recognize their possible behavior, their possible decision, their possible choice based on past, making reference to past choices, making reference to past decisions they're making, and their feedback so far. So this is just an example of unsupervised. So based on those previous behaviors, we can say, okay, this is the expected outcome of this very customer. This is just an example of unsupervised learning. Now, it helps business tailor their marketing strategy to different customer segments. Now, I've talked, or I'm saying this using human instance. What if we have programmed our system to be able to determine the customer behaviors? Now, there are certain things we have to put up in place. We have to tell the model that, okay, when a customer, for instance, who is interested in buying every new items that comes in, no matter how much it is, comes in, please do recognize. Now, we have to give it some past fields of those customer attitudes. If you, over time, we can have a chart with place, okay, Mr. A, Mr. B, every time we got a new set of products, he's always here. He makes sure he buys the stuff, no matter the price range. Now we can set up our model based on that. And once the customer or set of customers are in place, then we automatically know by high chance that we are getting something from that customer. Now, reinforcement learning, this is another sort of learning pattern. Now, this model learns by receiving feedback from actions in dynamic environments. Example are game playing, AI, and robotics. Now, these are popular machine algorithms I was talking about. Let's look at them one after the other. Now, we have a linear regression, we have a logistic regression, we have what we call the decision tree or random forest, then we have the neural network. Now, the linear regression predicts continuous value. Example, predicting stocks prices. You can see it predicts continuous value. Now, when those values are in place, we can actually, based on repeated pattern, or let's give ourselves a clear instance here. If you go into Forex, you can see the Forex signal. And oftentimes we want to, okay, for example, we are using our brain to play the part of the model training. We want to check past records of the Forex market, how the signals have been going up and down, and use that to predict the possible outcome of what is in front or what is to come. That's a pure example of linear regression. These days we have robots that can help us do that. Over the time we have been trying to do that with our own understanding, our own knowledge, our own set of level of analytics to see, okay, at this point we are expected to have this based on what happened maybe 2 weeks ago, 3 days ago. It hits a high, it hits a low, and it came back, to a down, sharp edge low. So over time we do this, and now we have bots that can, handle those things for us. And when we look at logistic regression, it says that for binary classification, example, spam and non-spam. Now, I mentioned the issue of spam and non-spam. Binary, that means usually between two things. And we want to throw in logistic regression in such set of data. In terms of predicting outcome for such set of data, we want to throw in logistic regression to handle that perfectly. And in machine learning, how do you know that your score are being your score is appropriate or rightly predicted? Now there's what we call expected value and predictive value. If you try to use decision tree in place of logistic regression, maybe hitting the wrong value. Now, at a point of 0.9, 0.5, close to 1, we say our model or our prediction is almost perfect. So if you hit in the wrong model in an instance where it's supposed to use, or let's say, there's this one we call random forest classifier, not here, and you hit linear regression, which is for binary for it, you get your accurate answer of prediction. Remember, machine learning is almost all about prediction. Don't let us have that in mind. So for you to hit accurate score of let's say 0.7 and above, we should be using the right model. Of course, there are usually options for us. At most time, it's always narrowed to 1 or 2, but getting the exact one could be an advantage. So let's look at another model here with another machine learning algorithm. I mean, now decision tree, random forest, this goes like together for classification and regression. For example, predicting loan default likelihood. Predicting loan default likelihood is like predicting those who are most likely, to get benefits of loan. Let's put it, for instance, you want to look at those within a locality that is likely to get a loan that is put up maybe within a community, and they are using certain criteria like, okay, what have you been doing? What are your assets in ground? What's the age bracket? And your level of experience. We want to use this to determine those who are capable, or who are possible, who are most likely to get this loan. We can use decision tree to determine this those who are likely to get this loan. So as I said, in this case, you can see that we have many variables to look at. We have, in this case, for example, we have maybe the age bracket, the past experience of the person, what the person does at the moment, the assets on grounds, and maybe let's put instance where you reside. So all these factors now, you can see binary algorithm will not function here, because we are looking at many variables put together to determine, okay, if this very individual or citizen is liable to, or most likely to collect this loan, and what are our chances of giving, this person the loan. So we use decision tree algorithm in this case. Now we have a neural network for complex pattern. For complex pattern recognition, image and speech recognition, I think it's one of the modern ones in place at this moment that came and changed the way or the interest in machine learning, when they included the case of neural network for image and speech recognition, and that became the turning point, the sharp turning point, I think, in the machine learning, giving the invention of AI escalation. Let's put it that way, because AI could have been there, yes, but more of what it can do, which has to do with image recognition, image formation, is made possible with the invention or the incept of neural network in machine learning. And let's look at key concepts in machine learning here: training and testing. If data is split into training and testing sets to evaluate model performance, trained model in machine learning is like a well-taught student. It has learned from set of data and can now make prediction of decision based on new data. Think of it as a research that has been perfected through practice. The more it practices, the better it gets at making accurate decision. There's something called overfitting. These are other concepts you can look at. How do we know something is overfitted? Our model is overfitted or underfitted. Because if there's an overfitting, there must be an underfitting. Now, model to closely match trained data and fail on new data sets. So you have been using certain set of training, the certain set of data training approach, and let's say you are training something to recognize. Let me use that instance again to recognize cats, and all of a sudden it has been working. It has been working. In this case, you are not labeling it. Cat structure, big, for large. Then all of a sudden you bring in something that look like a bigger cat, a cougar, and is unable to recognize it. You get it? So at that point, that model being used on that structure which you are trying to catch in, that in terms of the model recognizing the instance that okay, this is actually a set of cats, fails. So because you have only been feeding in small cats, and tiny cats, and now a bigger one comes in, it can't recognize it any longer. So that's the aspect of overfitting. Underfitting occurs when a machine learning model is too simple to capture underlying patterns in the data. This type results in poor performance on both the training set and new, as well as the unseen data. Now, evaluation metrics. Accurate score, precision, recall, and F1 score to assess performance. These actually are when we talk of F1 score, accuracy, measure, precision, these are actually they are actually statistical valuation for your score. After you've trained your model, you fit in your model, you've trained your data, you fit in your model. You want to go for that to get an accuracy score sometimes. And then these are actually evaluation metrics which you further use to break these things down. Then also we quickly look at application of machine learning. Machine learning could be helpful in the health sector. Machine learning models can analyze medical image to detect abnormalities such as tumor in a scan. Now, predictive analysis algorithm predicts disease progression, helping in early intervention and personalized treatment. If you go to the hospital, they could have in place some machine or some instruments that over time have been able to detect patients with certain disease symptoms, and when a new patient comes in with similar symptoms, it can be able to predict, okay, this is how deep or how light this ailment is, and it's possible to get based on recent. So from there they can predict the prescription at best to give to you. And in scanning as well, when the symptoms are being scanned or the hidden illness are being scanned, we can actually say this is how far it has gone based on, let's say for instance you were there some time ago and now you come back to take a scan again, then the machine can say this is how far it has gone, this is how fast it is going, and this is how slow it has been going. Maybe you are being on medication, then it can predict your progress from there. Another aspect is the aspect of finance, which is fraud detection. Machine learning identify unusual transaction pattern, now helping to prevent. So in this case, cut everything to just sum it up. Yeah, we are looking at a situation whereby you have been having data in terms of finance flow within your work system, and all of a sudden there is deep slide. and there is in place machine learning algorithm or program that have been detecting your in and outflow of funds. All of a sudden, it recognizes this unusual slide down. So before maybe a finance minister or whoever is in charge of it to come and say, okay, this is unusual, this is recognized, the machine learning can actually detect beforehand those changes based on recent performance and data being monitored over time. And if we look at retail as well as e-commerce, recommendation engines, algorithm, okay, recommendation engine. Now, algorithm suggests products to user based on their behavior and preference. Now, this one is also looking at preference, just like I said. For example, you have a customer whose preference has been a particular brand of product, and such customer comes around without wasting much of time. You can predict this is what the person will go for, even if there are other brands that looks more beautiful around or in stock at that moment. Now, manufacturing, quality control, image recognition algorithm inspect products on assembly lines to detect defects. Supply chain optimization, machine learning predict demands and improve inventory control, leading to efficient resource allocation. Now, we take a look at natural language processing, sentiment analysis, use in social media monitoring. Machine learning can gauge public sentiment on specific topics or products. Then the invention of chats, bots, and virtual assistants has been also the child or a spring up of machine learning. Now, future trends. Automating the process of choosing and optimizing algorithm, explainable AI, making models more interpretable by human. Look at edge computing, running machine models on device instead of centralized server. Now, personalization, tailoring experience in real time. Look at the visualization in terms of trends. We can say that timeline or infographic of future trend in machine learning. So these are actually things that we are actually looking towards emanating or being engineered by the presence of machine learning. So at this point, we can easily say that machine learning is a transformative technology impacting on numerous sectors. Success in machine learning relies on data quality, right algorithm, and clear evaluation metrics, and that is true.
Thank you so much, Justin. I'm sorry to
The
interrupt. It's already 9:45 a.m.
all
So we
right.
have to stop. Thank you so much, everyone, for joining. Please have a productive day.